Welcome back, everyone, to West Explains Best. We're picking up where we left off with imaginary numbers and complex numbers. So we're going to cover the complex numbers section. So essentially all complex numbers is talking about how we can have a combination of imaginary numbers and real numbers in the same polynomial. So in this case, A represents the real part, and this represents the imaginary part. So if we're looking here at this first problem, we see that we have 2 plus 3i plus 6 plus 4i. We're going to treat this very much, complex numbers, in the same way that we treat like terms. So if we had, for example, 2 plus 3x plus 6 plus 4x, you would do almost identical process. We'd combine the 2 and the 6 to get 8, and we combine the 3x and the 4x to give 7x. So that's how we'd handle that, and it's going to be almost the same process down here. So we have 2 plus 6 gives us 8. Because this is positive, we can leave these terms inside those parentheses alone as they are. Then we have 3i plus 4i gives me positive 7i. So you see that it's almost identical to like terms here, and that's anytime we're adding or subtracting. Here we're moving on to a subtraction problem. Notice how there's a negative out in front of the parenthesis. So the first thing I always do is I distribute that negative sign to both terms inside. Minus 2i. And now I'm ready to just combine like terms like I did before. So I have 6 and negative 3 gives me 3. Then I have 5i and negative 2i. Positive 3i. Final answer. Same thing here. We have a negative sign. First thing I'm going to do is distribute it to both terms. That gives me positive 9 and positive 8i. So now I'm going to combine it with negative 9 plus 4i. I have 4i and 8i, gives me 12i. And I have negative 9, gives me 8. Now the real number should be written first. Now technically this is the same answer, but notation kind of dictates that you should write the real part first. So this is kind of the preferred answer, but if it were my class, I would accept both. Just keep that in mind, though, because your teachers might not be so forgiving. Okay, so now we have multiply. So now we're going to multiply these complex numbers. Here we have 4i out in front, so we're going to distribute the 4i. We get 8i, just like we would if it was 4x times 2. We get 8x. 4i times 2, 8i. But now you have to be careful. Anytime you have I times I, you really have to be careful. It's not going to be 12i. It's going to be 12i squared. And anytime you have a squared term with I, you need to do something with it. You can't just leave a power of I alone. I by itself, fine, but if I has a power, you need to do something about it. So we're going to change I squared to its actual form, which is negative I. Don't forget to multiply by 12, and then we have 8i over here. So we have 8i minus 12. Again, we should rewrite it with the real part in front. Negative 12 plus 8i. That's our answer. So make sure you guys be careful with any time we have multiplication of I. Now, here's a more complicated one, but this is the same process with foiling. So first, outside, inside, last. But of course, you can go last, outside, inside first, or any other combination. As long as you hit all the necessary components, you're fine. So the first thing we do is we multiply 3 times 4, gives us 12, and then negative 6i. We multiply 5i times 4, we get positive 20i. This is one we have to be careful. We're multiplying i's together. We have positive, or excuse me, that's negative 10, and then we have I squared. So we need to be careful with that. Okay. Now we have negative 6i and positive 20i. That gives us positive 14, whoops, my pen's freaking out a little bit. 14i. Don't forget the 12, and that's plus. Now we need to change this, negative 10, and then this is times negative 1, because this I squared becomes negative 1. So 12 plus 14i plus 10, that becomes 22. I don't know about you. 14i, the real part's in front. There's our answer. So again, it's not too bad. Just make sure you take care of any time we have an I squared or I to a higher power. Okay. This is essentially the same problem, but it's purposely done to show you a special property. So this is essentially difference of squares. Difference of squares, but this is the factored form. So when it's factored like this, these two terms, let me write it up here, these two terms are conjugates of each other. So they're conjugates. Hold on, conjugates. And I'll put little stars next to it. Now this is important because it has kind of a unique effect when we FOIL it. So let's go ahead and FOIL it and I'll show you what I mean. So we're going to do these terms times each other, we get 9 minus 12i. Then we're going to do the middle terms, choosing light pink, purple this time. So we get 4i times 3, 12i, and then we get negative 16i squared. I squared, we need to be careful, just keep that in the back of your head. We're going to simplify now. 9, these cancel. Now that's always going to be the case with conjugates, is the outside and inside terms will cancel out. Essentially, you're always going to be left with the first and last terms with conjugates. So that's something to keep in mind. Minus 16i squared. Now, we can't leave it like I squared. Minus 16 times negative 1. That becomes 9 plus 16, or 25. Now, what do you notice here? Well, it went from two complex binomials to a real number. So solutions are always real numbers. Anytime you have these difference of squares or conjugates with complex numbers, you're going to have real numbers as answers. Now, what makes this conjugates for those that maybe were lost when I explained that part? Conjugates are when you have identical terms inside two parentheses being multiplied, but the only difference is there's addition in one and subtraction in the other. So that's what leads to this case. When it's real numbers is when we multiply complex conjugates. Okay, now complex conjugates allows us to do some kind of heavy lifting with division and other operations. So if we're looking at this problem, the hint is apply complex conjugates. Well, how do I divide this monstrosity here? 5 plus 2i. That seems really complicated. I guess that's why they call it complex numbers. Well, it's not as bad as it seems. So the first thing we had to do is we got to get that 2i out of the denominator. That makes it near impossible to divide. So how do we do that? Well, we apply what we know about complex conjugates. If we multiply this by its conjugate, we know that it will become a real number. So then it won't have an I in there, and we can actually do something. So we change it to 5 minus 2i. It's almost the same thing, we just change the plus to minus. But what we do to the bottom, we have to do to the top also. This is very similar to when we have a radical in the denominator, and we have to multiply like this. Even more so when we have something like 5 minus radical 3, and we multiply it by the conjugate 5 plus radical 3, which I covered in the previous sections of this chapter. So it's very similar to that. Let me shrink wrap it and put it to the side so you guys can reference it, if you want. So then we have, let's do the bottom first. I guess that makes more sense. So if you want, I'm just gonna show the FOIL again so you can see it for practice. But eventually you're gonna learn that once you multiply conjugates, you really only need to do the first and the last terms. Okay, so let me go ahead and get started. I'm gonna try to do this quickly so I'm not wasting your time. We have 25 minus 10i, positive 10i, minus 4i squared. Okay, there should be an alarm going off your head with that I squared. We cancel the middle terms, so we're left with first and last. So we have 25 minus 4 times negative 1. That's 25 plus 4, which is 29. So in the denominator, we get 29. That helps us. Now we have to do FOIL again. This time we do need to take our time. It's not just going to be first and last because the top is not conjugates. So we're going to do 8 times 5 gives us 40. Then we have 8 times negative 2i, negative 16i. Then we have 9i, we get 45i after we multiply it by 5. And then we get minus 18i squared. Okay, we got an I squared in there. We need to handle that. We have 40. Negative 16i plus 45i, that's going to give us 29i minus 18 times a negative 1. Well, I know that's going to become positive. Let me make this a little bit smaller so I have more room. This is over 29. Over 29. Change it to this. Okay. Equals. So now let's go ahead and finish this off. So we're going to get 58. That backwards, but you get it. Plus 29i. The reason why it's 58 is because this turns into plus 18. Okay, just FYI. Over 29. Now, a giveaway here that we're not done is you notice that there's 29 here and 29 here. Now, that could be fine, but because there's addition at the top, this first term also needs to be a factor of 29. And it actually is. So I was clued in that this could be simplified further because of the 29s. Then I looked at the 58 and I realized that 29 is a factor of 58. And now I absolutely know that this can be simplified further. So let's go ahead and show that here. So what I'm going to do is I'm going to factor 29 out of the bottom. You don't really need to do that, but I'm just kind of showing you that we're factoring both the top and bottom. Factor the 29 out of the top. So 29 times 2 gives us 58. Copy the plus sign. 29 times I gives me 29i. So what can I do here? Now that it's all multiplication, I can cancel the 29s. We're left with 1 in the bottom. We don't really need to write it. We'd get 2 plus I. That's our answer. So that's how complex conjugates actually really help us with some complex division of complex numbers. Okay, last one. This one's not as bad as it seems. Okay, to get the I out of the denominator, we need to multiply top and bottom by I. It's very similar to this one up here when we multiply top and bottom by radical 3. Very similar process. The reason why we do that is because I times I gives us I squared. Then we just have 1 times I in the top, I, plus I squared. So lots of i's we need to simplify because we have some powers. We have I plus a negative 1 over negative 1. Okay. Anytime you have a negative 1 in the bottom, essentially what you should do is you should change it, divide the negative 1 to multiply by negative 1. It's the same process, but it gives you a better looking answer. So we have negative 1 times I minus 1. We're going to distribute this to both terms inside. We get negative I plus 1. We need to write the real part first. 1 minus I, and there's our answer. So although you may get here, don't think that this is final. You're finally done. Try to simplify as much as you can, make it look a little neater, and there you go. That's all we have for this video. We're going to pick up with powers of I in the next one, so stay tuned for that.